Okay, I'm just beginning the stream. Just give me a second. Okay, in 1 second I should be good to start this. Just give me one more second. Okay, testing, check, check, check. Okay, cool. Now now I'm just gonna post the link to this and we can start. Okay, cool. So we're gonna continue today on the static bug analyzer, and I'm wanting to add a new analysis method, and I'll explain what I mean by that. So right now, how this bug finder, how it works is we give it a list of functions that we want it to check for, and it will just iterate through all of the references. Now, for targets with small code bases like CTO challenges, that can work fairly effectively. However, when you're looking at a massive target, one issue with that is you can get results for a ton of different code paths that realistically you aren't interested in and have no way to influence. So what I'm wanting to do now is implement a new method that will effectively, how it works is I give it a list of addresses that are the start of functions, and it'll effectively will iterate through that function and scan it for any of the functions that we're checking for, and then also scan the functions that it calls. That way, let's say that because a lot of code, so some with some different code bases, like let's say that there's a code base that or a code path that deals with a particular functionality that I'm interested in. Sometimes it will start from a single point, which will be that initial function entry, so that's why I'm wanting to have this in here. So cool, let's get started. Right here I have it just being the search method being that. I believe this is some code here that I already have written as I'm trying to implement this. For this, this is going to be the first address. I'll probably want to switch this over to a list format. That way, if it's a list, I can specify multiple entry points instead of just one. And we get the this is the function of the address. We get the P codes from it, and then we begin iterating through it. So, what I'm going to want to do, I'm going to want to implement two different. Also, if anyone has any questions, just feel free to ask in the chat. I'm going to want to implement two different sets for this. One contains the functions that are left that I will want to effectively continue to check, and another one contains the functions that I've already checked. That way we don't get into, because otherwise we would hit, like let's say for to hit a recursive function with this algorithm, it would effectively just keep enter into a loop since it calls itself. So let's go ahead and make that. Actually, first I'm just gonna run this just to make sure that it works. Okay, give me a second to make sure that this works. And this should work. Just gonna make sure that it runs before I start writing a bunch of code. That way, if for some reason I introduce a bug into this code base without realizing it, I it I would be able to figure that out and not have to waste time confused if it was code that I had written after it. So, okay, cool. It ran just fine. So this code is indeed functioning. So I'm going to get back to writing it. So we're going to want two different hash sets. Hash set. This is going to be for a function analyzed functions equals new hash set function. Okay, so this hash set is going to contain the functions that we've looked at, and this next hash set is going to contain the functions to analyze equals new hash set function. And how do we want to do this? We want to, so actually I'm going to copy this and move it into this if then statement here. So effectively what we're going to need is this while loop is where actually basically all of the processing will happen. We just need to initialize it first. Here we get the actual function for it. So let's add that to the functions, functions to analyze dot add calling func. We will need to, once this algorithm gets more fleshed out, implement support for having multiple different addresses or start points. For that, right now we're adding it to the, list or the set of functions that we need to analyze. So it's probably be a good idea to now do a check to make sure that we haven't analyzed it already. So here, if it does not contain it, then we will add it to the functions to analyze, and also add it to the list of analyzed functions. So with how I'm doing this algorithm, I'm going to add, whenever I add a function to the list of functions to analyze, I will also add it to the, also, hi whoever just joined. If you have any questions, let me know. We're going to add it both to the set of functions that we were going to, okay, what was I talking about? Oh yeah, how am I maintaining the set of analyzed functions and functions to continue analyzing? Whenever I add it to a function to the list of functions to analyze, I will also add it to the list modeling the functions that we've already analyzed. That way we just do it all then and don't get it mixed up. Let's see, this decompiles, actually, there needs to be two separate while loops. This first while loop will iterate through until the functions to analyze is empty. So effectively we'll iterate through until we have no more functions left to analyze in this manner. So that is empty. So while it is not empty, we will decompile each function and then iterate through it. So this outer while loop will iterate through all of the functions we want to analyze. This inner while loop will iterate through all of the P codes for that particular function. Now, for this, what are we mainly looking for? We are primarily looking for, what is it called? Call P codes. How can we detect that? Well, P codes have an opcode, so like C branches one, calls one, returns one, and we can just check if it's equal to call. Now, there isn't a specific enum for that. However, Let me see. Call offset. Oh yeah, the specific enum for the opcode is Ghidra program model. Pcode op call. So what we can do, and actually I'll show it to you here. We can go ahead and just print this here, and I'll show you the opcode. Okay, so this is, yeah. I'm gonna go ahead and print out. I'm gonna add some text here so we can easily tell it apart. 1, 2, 3. 4, 5, 6. And for the P codes, I'm just gonna go ahead and just to show, I'm gonna go ahead and print out the opcode value. Hey, code. Okay, let's see. Did I write all this code correctly with the right syntax? Oh yeah, I need to switch it over from TAC import to TAC process. Since I already imported it. Analyze functions. Oh yeah, this needs to be changed to analyze, not analyze. Missed the D. Let's see, does this run correctly? It does. Oh, yeah. I implemented, so this will iterate while functions to analyze is not empty. However, I didn't add a mechanism to remove the functions that we analyzed. So this is just going to run forever. So, okay, yeah, let's do something about that. And we see here that 1, 2, 3 space, then the 7 is actual number. I forgot to put a space between the 7 and the 4, 5, 6. That's why it's 7, 4, 5, 6. But yeah, as you can see, like the opcodes have a numerical value associated with them. So what we're going to do first, let's have a function current function equals, how do I want to do this? Is there, I'm going to look up get random, no, Java get first element of set. Is there like a dot pop? Okay, apparently it's dot get functions to analyze dot get 0. Well, I don't think, I'm just gonna look up Java, the docs for Java set. Let's pull it up here. Java set. Contains all equals, hash code is empty, iterator, remove all, size. Not seeing dot get, so this Stack Overflow article might be lying, but I'm just gonna go ahead and let's see what happens when I try just to do dot get. Okay, let's try this. Dot get can't find some but get first element of set. Looks like we might have to get an iterator for it. Now, my one problem that we might have with getting an iterator for it is we're going to, as this loop executes and as we scan a function and see that it calls other functions, this set is going to grow. Um, a linked list would probably be better for this. Yeah. Or some sort of like Java queue. A set probably is not the data. It'd be a good data structure for the analyzed for the enumerating like what functions we've already listed in, since then we could just have that of one looking for did we already look at this function. But for just keeping track of the remaining functions to analyze, a linked list would probably be better because also that that would allow us to actually probably be more like a queue, but yeah. I'm gonna look up Java queue example. Let's change this to a linked yeah, queue equals a linked list. What is so it's .add still, but poll will get and remove the first element of the queue. I need to import linked list and queue. Apparently it's in Java util. Let's keep all of the Java specific imports together. Okay, let's give it a second for it to run. Okay, I'm just gonna Java import linked list. Java. Okay, let's just try java.util.all. So many ads just came up. Cannot find symbol.poll. Well, looking at the docs on the other screen, poll 2059. Functions to analyze. Oh, I switched over analyzed functions to a queue, not functions to analyze. Okay, so this is running, and we see that it ran only once, meaning that it did successfully remove the function and analyzed from the linked list, so that is good. Progress is being made. Now what do we need to do? We need to add the functionality for it to check other functions that are called. How can we do this? We can add an if then statement if current pcode dot get opcode is equal to a call opcode, which you see right here. We can then, okay, so it's calling a function. We can check if analyzed functions dot contains current pcode. Let's change this to if it does not contain the, oh wait, no, we need to get the function from it. Okay, cool. So address function address is equal to get address from offset. For call pcodes, the first argument to the pcode or argument is an input is used interchangeably in this context. The first input to the pcode is the address of the function to be called. So what we can do is we can get inputs. I'm going to look at the Ghidra docs for this again. Ghidra Java. What's the right term here? Ghidra Java pcode. Pcode up. There should be like a get input at get opcode, get num inputs, get input. Let's make this easy. var node call input equals current pcode dot get input, get the first input, and then the offset equals current pcode dot get offset. So this is the function. I'm gonna add a few checks here. If current pcode dot get num inputs, which is from right here, if the number of inputs is not greater, if it's not greater than 0, continue. If, let's see, I'm going to add a check here. If the call input dot is not constant, continue, and we can change this to the negative. Now, one thing I'll need to do as a part of ensuring code quality for this is basically everything. I'm going to want to write a check just to make sure that the type of value I'm getting is indeed what I need it to be and what I'd expect. Because reason for this being is the problem of decompilation is a really hard and complex one, and it faces a ton of different edge cases. So if this is used enough, I'll probably encounter a scenario where something happens and I get a value that I'm not expecting, and I'll need a check there to catch those edge cases, otherwise I'm just going to crash. So we get the offset and then address function address equals get address from offset. Next offset, going to rename this to next offset, and then function next function equals get function with address function address. So here we get the function that is being called by the P code, And if this hash set does not contain that function, we will add it to the list of the queue of remaining functions to be analyzed, and we'll also add it to the functions that we have analyzed. Also, what adding a function to the list of analyzed functions at the time that we also insert it into the queue of remaining functions to be analyzed, what that does for us is prevents a scenario where, let's say, we analyze a function and we see that function x is being called, so it gets inserted at index 5, but the next 2 or 3 functions that we check also call function x, and then x just gets inserted multiple times into the queue of remaining functions to be checked. So yeah, hopefully that will help guard against that and other potential problems. And yeah, I'm going to try running this. Now, since I added the ability for it to scan through all of the functions, this should get offset. Okay, there. Get offset apparently is not a Ghidra node function. Ghidra node. Let's take a look. What do we have? Get space. Get offset. Current. Oh, I did current code. No, wait, call input. Oh yeah, this should be call input, not current P code. Okay, let's go ahead and run this. Now, okay, cool. So you see here that it is running. Now, one thing I just realized is this address right here. I think when I was initially doing this, I checked and verified this address was the main function. However, this reads 000 binary. It's just one I picked randomly, so I probably want to see what is the address of main for it. It is 1189. Oh, it's main. Okay. Add load cast indirect copy pointer sub indirect int load C branch return. So one thing that's a bit weird. I'm gonna add some print statements just to make sure of this. I want to add a print statement for each function that we analyze. Reason for it being is I think there's a problem here where I'm pretty sure the main function of this function calls other functions, but looking purely at the P codes of here, it looks like it's only listing the P codes of the main function. So this function tracing algorithm does not appear to be working at this time. So we need to fix that. What I can do is I'll add a print statement here. Print line. Looking at function current function. Let's try this. Looking at function main, so it is only looking at main. So what could be the problem? Could be a problem with some of our pretty sure it's a problem with one of these checks I'm doing. I'm gonna try commenting it out. Could it be? Don't. Oh, actually, it's not that. Because looking at. Well, actually, let's just see. So it was one of these. Yeah, pretty sure it's this call input is constant. I'm gonna try adding some two print statements here that should illuminate the problem. So I'm gonna print out if it is an address or is it a const? Well, is it an address and is it a constant? Very true. So in all cases, it is an address, but not a constant. Yeah, not a constant. So what I'll go ahead and do is change this from is a constant to is an address. And this should work exactly as intended. Okay, that looks like it worked just fine. So what is the next part? So we can iterate. We have the portion of the algorithm that is responsible for. We give it the start of, let's say, like a function that we know is the start of a code path that we want to analyze. It can go through, at least in this brief POC, and propagate the functions that it calls and analyze it. Next, we actually need to put in the part where it's actually, is this like, let's say we're looking for read calls and it gets so called, is this a read call? And if so, let's actually like analyze the read call. So how is this going to work? So right here we already have the portion where it'll like look for a call, so that's part of what we need to do here. And we have it that we get to the next function. What I think would be the best thing to do is I'm going to take a look as to what data structures I have that already model the functions that I'm analyzing, and it's probably like in a hash map or something like that, and I can just like check, is this a function that we want to check for by seeing does it exist in the hash map. It does, cool, kick off the secondary analysis, or it isn't, okay, cool, we'll continue propagating through it. So let's see. Okay, oh yeah, I just started scrolling without thinking. So, analyze function. Function mapping. Func mappings. What is the type for the func mappings data structure? It is a function to an integer. Okay, so func mappings, this is a hash map that I did. Reason for it being is it's supposed to actually say like, hey, because sometimes like certain environments will like append sorry, append a few characters or like to the end of it or something like that. func mappings, the purpose of that data structure is actually say like, hey, these 5 functions, yeah, apply the like read check to them. And the key to it is the function. So what I should be able to do is say if func mappings dot contains key, which will just see, yeah, basically does this function exist in the list of functions that we're actually looking for. So if dot contains key, next function, this is going to be else if. So how do I do this? Current program, what is this do? Analyze function target. Next reference. Got. Okay. So the analyze function, this is the primary function that we pass a reference to actually get. Okay, yeah, this is the primary function that we pass things to analyze it. How do we do this? We just call it pass the actual function. So like if we're looking at read, to pass the read function and the reference to the call. Now for this, we have the function, which is in this case it's just gonna be next function. What we do not have is the reference. So I will need to get a reference somehow for it. I'm gonna comment out this line since right now if we run it, it will crash. Now how can we get a reference? Well, current program.get reference manager.get. So here we're using current program.get reference manager, and that can call .get references too. Well, I wonder if we can. What does get reference manager return? Let's see that first. Returns a reference manager. Is there like a get references at? Get all references from the specific address. So what we should be able to do is we should be able to get like the address of from the P code and use that to get a reference. So what we will need to do is there like a is this P, yeah, this is P code. Get input. Is there a get address for the P code? No, it does not appear like there is one. What analyze function? What does it actually use a reference for? Let's look at like %s. Does it actually use the reference for anything? Let's see. Reference. Oh yeah, dot get from address. It does actually use the reference, so we do need to get it. The question is, how can we get it? Dot get inputs. Get opcode. Get output. Get parent. Get sequence number. Get slug hash code. Not seeing anything here that will help me with this problem. So what is the root problem? We need to identify the address which is tied to the P code, which the function call that we're looking at happens. How can we do that? Trying to so I'm just gonna like Ghidra get address from P code. Let's take a look at this. Not seeing anything that will help. I just thought we might be able to. We could iterate through all the references to a function and then get the P codes from that, but that will be really messy and really janky. I don't think that's a good way to do it. That's just one way that popped in my head. There has to be a wait. Get P code up AST. Get parent set base. Get P code opera. Dot get. Okay, so this is saying it has a dot get address. That's why I was like, for so long, just thinking like we should probably just use dot get address. I'm just gonna try just calling dot get address on the P code and let's just see what happens. If this doesn't work, then I might try getting a P code op raw and then doing that, but one step at a time. I'm gonna add a string here. We want that way we can easily identify this. Current P code dot get address. For now on, if I no, sorry, monitor for a second. My VM just went back to one screen. Okay, getting back to this. Okay, get address. Let's call this. Can't find address. P code up. So, can we go from a P code up to P code up raw? Okay. No. Okay, so this stream has been going on for basically 45 minutes now. So I'm gonna go ahead and end it here. Thank you, gamers, for watching, and see you next time.